All right, so let's go ahead and work on solving trig equations part 2. We did problems 1 through 3 in part 1, so we're just going to go ahead and pick up with number 4. So we're going to solve -3 plus cosine x is equal to -3. So of course, if I want to get the cosine x by itself, I'm going to go ahead and add 3 to both sides. And that gives me cosine x is equal to 0. Now, if you recall, cosine x equal to 0, that is going to be on the actual axis. So it's either going to be on the x or the y. So think about the unit circle, what the ordered pairs are. So here, this is 1, 0. This is 0, 1. This is -1, 0, and this is 0, -1. So cosine is the x value. So looking here, where is cosine of x 0? So you're looking for the x coordinate that is 0, which is here. And that happens at 90 degrees, which is pi over 2. And it happens at 270 degrees, which is at 3 pi over 2. So, and I didn't specify our interval for here when we were solving it. So for a, we'll say the interval is from 0 to 2 pi. So then x is equal to pi over 2 and 3 pi over 2. And then we'll say on the interval from -infinity to infinity, x is equal to pi over 2 plus 2 pi n, and then 3 pi over 2 plus 2 pi n. Okay? Cross that over. So now let's look at number 5. And we're going to solve -2 plus 5 sine x is equal to 4 square roots of 2 minus 2 minus 3 sine of x. So we want to get, again, the sine by itself, so we can move some things around here. First, I will go ahead and add 2 to both sides. So that gives me 5 sine x is equal to 4 square roots of 2 minus 3 sine of x. Then I'll go ahead and add 3 sine x to both sides. So I get 8 sine of x is equal to 4 square roots of 2. And then I'm going to divide by 8. So I get sine x is equal to, this will simplify to the square root of 2 over 2. So now going back to your unit circle, think about being on the 45s. The ordered pair is the square root of 2 over 2, comma, the square root of 2 over 2. Think about where is sine positive. So all students take calculus. So sine is positive here in quadrant 1 and here in quadrant 2. So this will be our quadrant 1 answer. And from here to here will be our quadrant 2 answer. So this, again, it was on the 45s, like we said. So that makes this angle 45 degrees, which is pi over 4. Using that as a reference angle, this is 45 degrees. So from here to here is 135 degrees, which is 3 pi over 4. So then we have, and again, I didn't specify interval. So that's going to be from 0, let's say from 0 to 2 pi. And our answer would be x is equal to pi over 4, comma 3 pi over 4. And then if I specify the interval from -infinity to infinity, that's going to be x is equal to pi over 4 plus 2 pi n, and then 3 pi over 4 plus 2 pi n. So hopefully you grasp these two right here, and they're basically in line with the first 3 problems that I did in part 1. So now I'm going to kind of switch things up a little bit, and continue solving them, but I'm going to add another element to the problem. So let me go ahead and flip this page. All right, so number 6, we're going to solve 2 cosine 3x minus 1 is equal to 0. So you can see the difference here that the period is going to change, and I'll show you how we take care of that as we go through this. So we're going to get the cosine of 3x by itself. So we're going to add 1 to both sides, and that would give us 2 cosine 3x is equal to 1. And then we're going to divide both sides by 2, and then we get cosine 3x is equal to 1/2. All right, so now what we're going to do is we're going to figure out when is cosine x equal to 1/2, not cosine of 3x, when is just cosine of x equal to 1/2. Then I'm going to correct for the fact that the period is changing. So if you think about your sines, all students take calculus. When is cosine positive? That's going to be in 1 and 4. Hopefully you recognize that being that it's the 1/2, you go to the unit circle. That's going to happen at pi over 3 or 60 degrees here. So it'll be pi over 3, which makes this reference angle 60 degrees. So going from here to here would be 5 pi over 3. And that takes care of the two angles if we just had cosine of x. So now to fix for the period, what I'm going to do is I'm going to take this 3x and say 3x is equal to my one answer, pi over 3, and then 3x is equal to 5 pi over 3, and I'm going to solve that. So really I can just multiply both sides by 1/3. So I get x is equal to pi over 9, and then same thing, multiply by 1/3 to both sides, and I get x is equal to 5 pi over 9. So now these are the answers within this period. Well, what is that period? This period is equal to, remember, it's 2 pi divided by b, so 2 pi over 3. b is 3 here, so 2 pi over 3. So these answers right here are within this one period from 0 to 2 pi over 3. So this would be the answers if we're going from just within one period, which would be 0 to 2 pi over 3. But I'm asking you between negative infinity and to infinity. So what we do is we got x is equal to, we have our pi over 9 plus, remember it's the period n. Well, what is the period? The period is now 2 pi over 3 for this. So it's plus 2 pi over 3n, and then it would be 5 pi over 9 plus 2 pi over 3n. So that would be our answer for this based on the interval from negative infinity to infinity. All right, so let me move this up a little bit. So I'm looking, make sure I get the whole page there. All right, so now we're going to look at number 7, and we're going to solve 3 tan x over 2 plus 3 is equal to 0. I'm going to do the same thing in the interval from negative infinity to infinity. So again, look, you can tell that the period is going to change just like number 6. So we take this, so 3 tan x over 2 plus 3 is equal to 0. So I'm going to go ahead and subtract the 3. And that would give me 3 tan x over 2 is equal to negative 3. Then I'm going to divide by 3. And I get tan x over 2 is equal to negative 1. So just like we did before, we want to know, well, when is tan x equal to negative 1? When is tan x equal to negative 1? Well, think about the unit circle. On the 45s, the ordered pairs are the same except that maybe if you're in quadrant 2, the x coordinate is negative, the y is positive. So it's just a matter of the signs. Well, if you want to get a -1 and think about tangent is, when is tangent negative? Tangent's negative in 2 and it's negative in 4. Well, what's the period for tangent? The period for tangent is pi. So I only need to go from here to here. Well, that means my answer is going to be in quadrant 2, which goes from here to here. And on the 45s, that means that this reference angle is 45 degrees. And then that would put me at 3 pi over 4. So now I need to correct because I have my period change over here. So I'm going to say x over 2 is equal to 3 pi over 4. Because again, this 3 pi over 4 is the answer for just when tan x is equal to -1. This is going to correct for the fact that we have a period change. So I'm going to multiply both sides by 2, and I get x is equal to 6 pi over 4, which is equal to 3 pi over 2. Now, if you want to look at the period here, so this, the period for tangent is pi, so it would be pi over b. b is 1/2. So x over 2 is 1/2. So pi divided by 1/2 is equal to 2 pi. So look at this answer is basically from 0 to 2 pi, we get 3 pi over 2 would be the answer that we'd want if we're just within one cycle. Well, we want to go from -infinity all the way to infinity. So we say x is equal to 3 pi over 2 plus the period n. Well, what's the period of this? It's 2 pi, so 2 pi n. And that would be the answer for number 7. So I'm going to take a break and end this part. This will be part 2, and then I'm going to pick up with number 8 on part 3. Talk to you soon.